Okay, okie doke. Here we're back again, and I'm picking up with this is section 2-5 chain rule, working on that chain gang here. And we're on problem number 6. We just finished that up, and I actually didn't quite finish it. Here it is. That what I said is that I'm gonna kind of get a common denominator for this, and you can see that there would be some simplification in the top because I could combine this square root of x squared plus 1 times square root of x squared plus 1. That would be just x squared plus 1. We now have a common denominator, so you'd be able to combine numerators pretty nicely. But in the interest of time, you try that on your own and see if you can get that answer. And if not, contact me. You just want to simplify it a little bit. It's just kind of messy. So here, let's go on to finding the derivative of the next one. I'm going to use the chain rule and the quotient rule. The quotient rule and chain rule. It's a fraction, obviously. So what I'm going to do is set it up, and I'm going to do f prime. So I'm going to set this up as f prime of x is equal to, I'm going to say this as we're doing it, low d high. So it's going to be x squared plus 3, the quantity squared, low times the derivative with respect to x of the high, which is 3x minus 1 squared, low d high less high, 3x minus 1 squared, times the derivative with respect to x of the low, which is x squared plus 3 squared. Okay, so that's all over low squared. So the low squared, so it's going to be x squared plus 3 instead of squared. That's going to be to the 4th power. So let's go over what our task is next then. We've got our quotient rule all set up. So the two parts that need to be resolved within this before we start to simplify are the fact that we have two derivatives to accomplish. Now, there's an easier way as you're working with these to factor out common factors that exist, but let's take a look at this first. So we have x squared plus 3 squared. That just stays there. Now we're going to take the derivative of this. Now, I want you to watch as I do this. I'm going to just, instead of doing the whole chart and everything, I'm going to look at this as a power, and I'm going to use the power rule first. So it's going to be the 2 is going to come out front. I'm going to keep my 3x minus 1, and I lower the power 1. So it's just a 1, but we normally don't write that. Okay, so then I'm going to say times the derivative of the inside function, which is 3. Okay, and there you have it. Okay, so that's that derivative of the inside, the derivative of the high, as you say, the upper. I always say low d high, less high d low. Okay, and it just has always stuck with me. Okay, 3x minus 1 squared gets put in there, and then we now take the derivative of x squared plus 3 squared. So what I'm going to do is the same thing. I'm going to bring the power around front, so that's going to be 2 times the quantity x squared plus 3, and then I need the derivative of the inner function, which is x squared plus 3, so that's going to be 2x. The derivative of x squared plus 3 is 2x. Then I'm going to take this, and I'm going to put that over the denominator. X squared plus 3, and that's to the 4th power. Scissors, bring this down a little bit. Okay, and maybe bring this down a little bit. Okay, so now that I have that, I'm going to let's clean this up a little bit so we can read it a little bit better and fit everything we need to fit in. Okay, we have that. Let's make this a little smaller. Okay, so now what I want to do is I want to factor out common factors. Oh, by the way, I just wanted to highlight here. This is the derivative that you see above, the derivative of x squared plus 3 squared. Okay, so we have those two parts done. Now, if you look at this, we have a lot of common factors. So I'm going to say, let's look at a GCF factoring of what's in the numerator. So I have a common factor of x squared plus 3 that I could pull out, right? Just one, because look at the minus sign here. You got to look on the left and the right. You've got x squared plus 3 in both terms in the numerator. Remember, your two terms are products. So I've got x squared plus 3. I've got a minimum of one factor. Then I've got a factor of 2 as well, so I'm going to include the 2 here. I may change the order of that, of course. And then I've got a factor of x squared plus 3 and a factor of 3x minus 1, right? So I have a factor of 3x minus 1 in both terms. Okay, that is it for now. So I could pull that out, and this makes your simplification a little easier, but I'm not sure that you guys have been used to factoring out a monomial, or a binomial, except when you factor by grouping. So just get a hold of this. Here, let me go back one little tiny erase mark. Let me see if I can get rid of this. Okay, because I want to highlight what I'm going to pull out. So I'm going to pull out one of these. I'm going to pull out the 2. I'm going to mark the 2 in both of them. I'm going to pull out a 2, and I'm going to mark a, I don't want to use the same color. Let's use that. Okay, then I'm going to mark a 3x minus 1. Now notice I didn't mark the ones that were squared because I can't pull the whole thing out, but you can see what's going to exist. There will be one factor of the binomial left in those 2 cases. So here we go. So I'm going to pull out a 2, an x squared plus 3, and a 3x minus 1. And I'm going to put up a parenthesis. Now, I want you to look at the original, and maybe I should use the orange for the x squared plus 3, just for at least the inside of it. Okay, and then maybe a pink just for the inside of it. I want to be careful not to get the outside, implying the second factor. So here we go. So let's look to see what's left. We have a factor of x squared plus 3 left in the first grouping, and a factor of 3. Here's your minus sign. Okay, then now the second grouping has a factor of 3x minus 1. And what else do I have? I have a 2x, right? Okay. Okay, that's the numerator. And then over the denominator is an x squared plus 3, and it's to the 4th power. But notice we have an x squared plus 3 here that I can cancel and make that a 3. I'll just clean it up a little bit. So what I'm going to do with this one, in the interest of time especially, is we're going to leave the numerator in factored form. So here we have a 2, then I have a 3x minus 1. Well, let's kind of simplify that a little bit. And then over, how much am I going to need here? I'm not quite sure. So let's do a little aside with this. We have a 3x squared plus 9 minus the quantity 6x squared minus 2x. And that becomes then, of course, a plus, a minus, plus. So adding like terms, what do we get here then? We have to those 2 terms. So what do we get? We get a 9 plus 2x. 9 plus 2x minus 3x squared. And that would be over x squared plus 3, and that would be cubed. One of the things that you can do, I know in the interest of time and keeping videos short, is you can slow the speed down. My voice might kind of go really slow like that, but it might help you as you're going through some of these problems. You can always pause and go back a step too if you want to do that. But this idea of factoring out a greatest common factor that's based with binomials, it's going to come a little bit slow at first, but once you work with this a few times, it makes it a lot easier than having to multiply out, like say, let's go back here, multiply this out or that out, and the x squared plus 3 squared, in both cases, the 3x minus 1 squared, and it truly makes your answer a lot easier. We have number 8 yet? Okay, number 8 I'm going to shorten a little bit and let you try this out with your calculator too. So from 2004 through 2013, the sales per share S in dollars for Dollar Tree can be modeled by this equation. It only gives you from 4 to 13, so you're thinking 2004 to 2013 because it tells you that T is the year with T equals 4 corresponding to 2004. Use the model to approximate the rate of change in the sales per share in 2010. Okay, So I've done the derivative already. So what I did is I brought the exponent around front using the chain rule. We're doing the power rule first. So that is the derivative of the outer function. And then I'm going to take the derivative of the inner function, and I get this. So if you want to know what the rate of change in sales per share in 2010 is, you're just going to plug 10 in. You're just going to say 2, and you can put this in a calculator if you want. 120, right? 120 t squared. So instead of t, you're going to put in 10. So 10 squared plus 0.140 times 10 plus 2.30. And then you're going to multiply that times the quantity. Times the quantity 0.0240 times 10 plus 0.140. Okay. And then put that in a calculator and get your answer. Okay, if you need any help, please email me. And I'm glad you're seeking the help of other teachers at this point. Anybody, siblings, if you have any questions, you can, of course, email me. And I'm trying to get back to all of you. But take care, and I'll see you soon. Bye-bye.